In this short video, I'd like to demonstrate the use of the chain rule to evaluate derivatives. The two examples I want to share with you are both a little bit challenging, not because any single part of the example is a challenge, but because they just get a little bit more detailed than some students are ready for. I want to encourage you to practice examples like this, and the more you practice it, the easier they're going to seem. So here's the example. We have f of x equals cosine of 3x to the 7th power. I may have read that a little differently from how you were seeing it, but this notation that you see, cosine and then 7th power 3x, it's the same thing as saying the cosine of 3x to the 7th power. To do this example, I have to first recognize that there are three different functions going on. In the outermost function, we've got something to the 7th power. Next, we have the something is a cosine of 3x, a cosine of something. And then in the very innermost, we've got a 3x. So the challenging piece to this example is recognizing that we're going to have to do the derivative and then chain again. So buckle your seatbelt, get ready for this one. It's not really challenging. It's not that any part of it is really challenging. It's just remembering to keep chaining until we drill down all the way to that 3x. Here's what it's going to look like. I'm going to start by doing the derivative of something to the 7th power. And we know that the derivative with respect to x of x to the 7th power, applying the power rule, is 7x to the 6th power. So if I were to think of this as a big something, like the something to the 7th power, it might seem more obvious when I do that to say that then I'm going to have 7 times that something to the 6th power. Do you see how that's really no different from what we did here? The derivative of something to the 7th power is going to be 7 times that something to the 6th power. So if it's just a nice simple x, it's just the derivative with respect to x of x to the 7th is 7x to the 6th power. Well, we don't have a simple little x here inside our bracket. What we have is a cosine of 3x. So we have 7 times the cosine of 3x to the 6th power. That's the first step. And what I have to remember to do then is then say times the derivative of that something. And that something is the cosine of 3x. So when I have something raised to the 7th power, the derivative is 7 times the cosine of 3x raised to the 6th power times the derivative of the cosine of 3x. Let's continue this down, and I'm going to copy, I'm not going to lose anything. I'm not going to leave anything out or leave it behind. So we have 7 times the cosine of 3x to the 6th power. And then to do this derivative of cosine of 3x, I'm going to first address the outer function, that's the cosine, and the derivative of cosine is the opposite of sine. And then I have to remember to do times the derivative with respect to x of the 3x. Let's break that apart and make sure everyone follows what we've just done. When we go to do this derivative of cosine of 3x, the derivative of cosine of whatever is the opposite of the sine of whatever. So we have the opposite of sine of 3x. And then I simply have to remember to, oh yeah, chain. So the chain is going to be times the derivative of the 3x. Let's keep going. We only have one more to go. I'm not going to be lazy and forget to carry this down. And in fact, I'm going to rewrite this in, oh, that's not what I meant to do. I'm going to rewrite this cosine of 3x to the 6th power in the better notation that looks like this. Right, so 7 times the cosine to the 6th power of 3x times the opposite of sine. How about if I take that opposite and bring it out here now? Opposite of sine of 3x. And now all that's left is the derivative of 3x. Easy, that's 3, right? The derivative of 3x is 3. And so here's where that 3 comes from. Blend it all together. What would I get? I'm not going to lose that negative. So we've got this, the opposite of out front. The opposite of, and then I'm going to do 7 times 3 is 21. Cosine to the 6th power of 3x times sine of 3x. And there we have it. That's it. Now, if this didn't make sense to you yet, if there's a part of the example that didn't make complete sense yet, I'm going to encourage you to hit that rewind button, go back to the start, and try it again. You want to really know that you've got this down, that you understand how to do it, then go back to a blank page where all you see is f of x equals the cosine to the 7th power of 3x, and check yourself. Can you go all the way through the process and get this final result, negative 21 cosine to the 6th power of 3x times sine of 3x. Can we try one more in this video? Let's look at this square root. Now off to the side, I can see that I've got on the outside, I've got this derivative of a square root. I have memorized that as a formula. If you haven't memorized it, you could see it as the derivative of x to the 1/2, and then applying the power rule, you get 1/2 x to the 1/2 minus 1, so negative 1/2, which is going to be 1/2 times x to the 1/2, which is 1/2 square root of x. So you could go through all of this to the power, applying the power rule to get the square root, derivative of the square root, but I'm going to really encourage that you get familiar with that one and just memorize it, right? And then let's look at the inside function. Inside, we've got this polynomial, so all we're going to do is use the power rule here. 2x cubed plus 4x to the 5th minus 13x. The derivative is going to be 6x squared plus 20x to the 4th minus 13. Let's put it all together, and we'll see that if we're doing the derivative of f of x, that's going to equal 1/2 times that square root. It's the square root of 2x cubed plus 4x to the 5th minus 13x. How did I do that? I applied this, that the derivative of a square root of something is 1/2 times the square root of that something. And our something in this case is the 2x cubed plus 4x to the 5th minus 13x. But wait, there's more. Don't forget the derivative of the inside function now. So we'll say times the derivative of that inside function, 2x cubed plus 4x to the 5th minus 13x, which we've already found as the 6x squared plus 20x to the 4th minus 15. So when I put it all together, I'm going to write this twice. I hope you get to the point where maybe you'd skip this step, but just to make sure no one has even 1 ounce of confusion here. Let me show you what I'm doing here. We have 1 over 2 times the square root times 6x squared plus 20x to the fourth minus 13. And it's as if that's all over 1 if you want to picture it as a fraction. So do you see that I could move this over to be part of that denominator? Or I'm sorry, numerator. So the final result in simplified format would look like this. 6x squared plus 20x4 minus 13 all over 2 square root 2x cubed plus 4x to the fifth minus 13x. Don't try to get fancy with any kind of simplifying from here. The only simplifying we might be able to do would be if, by chance, we could reduce this 2. But now we could only reduce the 2 if it goes into 6, 20, and 13, which it doesn't. It doesn't go in with the 13, so we can just leave it as it is. And that's it. Well, I hope you found this video to be helpful. If you do have some questions about it, I hope you won't hesitate to reach out to me. Be happy to give you a few more examples to work with.